7 learners, it's math o'clock again. I know that after a 2-week break, you are very much excited with our new lessons. For the week 5 lesson, you learned how to multiply polynomials and expressions using the horizontal method and vertical method. Recall that to find the product of two binomials, we use distributive property of multiplication over addition. Using this property, we multiply every term of one binomial by every term of the other binomial and combine like terms. This time, we will deal with special products. There are instances that when we multiply polynomials, there are patterns formed in their products or solution, and this made them special. After going through this video, you are expected to use algebraic methods to find the following. First, product of two binomials. Second, product of the sum and difference of two terms. Third, square of a binomial. Fourth, cube of a binomial. And lastly, product of a binomial and a trinomial. The first special product that we are going to deal with is the product of two binomials. Getting the factor of two binomials is very easy if it is done in a systematic way. That's why we have the FOIL method. FOIL is an acronym which will guide us in solving the product as it gives us the order which will be multiplied first. So the first to multiply are the first terms. Since, say for example, we are multiplying the binomials a plus b and c plus d, and the first terms are a and c, so we are going to multiply them first. We multiply a and c followed by the outer terms. The outer terms are a and d. Then, the inner terms or the middle terms, which are b and c. And the last terms will be multiplied next. So, the last terms, for the last term, we multiply b and d. Take note of the arrangement so that you won't be puzzled. So, the final product, or the product of a plus b and c plus d, is ac plus ad plus bc plus bd. This will serve as our general formula. But later on, we will not be dealing with a and b. We will be dealing with the variables. We will just substitute this into this formula. So let us try to solve one problem. We multiply the quantity x plus 2 times the quantity x plus 3. Multiply the first terms and they are the variable x. So x times x. We write x times x. And then next is, we have the outer terms. As you can see, the outer terms are the terms in the outermost part of our statement or expression, and they are x and 3. So we write them. That will be placed on the second term. We have x times 3. And then, the next is we multiply the inner or the middle term. The middle terms are 2 and x. So we have 2 times x. Okay? And lastly, we will multiply the last terms. The last terms are the last terms for each group of polynomials. So for the first binomial, the last term is 2, and for the second binomial, the last term is 3. So we multiply 2 times 3. So there we have it. We have written and solved for the partial products of our two binomials. And we did it systematically using the FOIL method. After that, we multiply and simplify the equation. All terms must be simplified. Okay, so x times x is x squared. X times 3 is 3x. 2 times x is equal to 2x, and 2 times 3 is equal to 6. Wait, it doesn't end there. As you can see, we can still combine 3x and 2x because they are similar terms. So, combining these two terms, we will be having x squared plus 5x plus 6. So, the product, if we multiply x plus 2 and x plus 3, is x squared plus 5x plus 6. Isn't it easy? Take note, dear learners, that as long as you are familiar with the first, outer, inner, and last terms of two binomials, multiplying binomials is very easy. Always remember FOIL method, okay? Let us now move to the next special product. Okay, so next is the product of the sum and difference of two terms. The product of the sum and difference of two terms is given where the first and the second terms of the two binomials are the same. So as you can see, we have the same terms. Hence, the only difference is the operation sign given by the formula a plus b times the quantity a minus b equals a squared minus b squared. The general formula a plus b times the quantity a minus b equals a squared minus b squared is derived using the FOIL method. And from here, we can see the pattern of the product of the sum and the difference of the two terms, which is a squared minus b squared. So this, it seems like this is the shortcut, okay? So take note, dear learners, if you can see that you are multiplying two binomials with the same terms, wherein the only difference is the operation between these two terms, you can apply the formula a squared minus b squared. Let's try to apply this into practice. Okay. Let's have this example. Find the product of x plus 5 times the quantity x minus 5. As you can see, the first term are the same with the second term. So we can use the special product to solve for this. So let a be x and b equals 5, and then substitute this to the general formula, which is a squared minus b squared. So we have x squared minus 5 squared. Then we simplify. We are going to simplify x squared is x squared, then 5 squared is 25. That is 5 times 5. The operation between this is always minus or negative. Therefore, the final answer, or the product of x plus 5 times x minus 5, is x squared minus 25. This is the final answer. Okay, let us have the square of a binomial. The square of a binomial, a plus b quantity squared, is the product of a binomial when multiplied to itself. FOIL method can be used in finding the general formula of the square of a binomial. So if you are going to multiply the same binomial, the square of a binomial is used. If we multiply a plus b to itself, the result is a squared plus 2ab plus b squared. Same is true with a minus b. So the only difference is the operation between these terms. So if you are going to multiply a minus b to itself, the result is a squared minus 2ab plus b squared. The first term of the product is always, as we can see, let us observe this product. The first term of the product is always the square of the first term in the binomial. So we always square a, and then the second term of the product is always twice the product of the two terms in the binomial. So to get the middle term, you always multiply a and b and then times or double it. And for the last term of the product, it is always the square of the last term in the binomial, which is b. Again, I will repeat. The first term is always the square of the first term, which is a. The second term or the middle term is always the product or twice the product of these two terms, a and b. So we multiply a times b times 2. And then for the last term, we have b squared. We square the last term. To further understand and learn this special product, let us take a look on the next example. Okay, so for this example, we are going to find the product of x plus 4 times x plus 4. This expression can be simplified as, or can be written as x plus 4 quantity squared. And this time, a while back in our general formula, since we are using a and b as our variables, this time we will be using x and constants. So we let a equals x and b equals 4. So applying the general formula, we square the first term. So since the first term is x, I am going to square it. And then for our middle term, we write 2, that is 2. And then we copy the first term, which is x. And then the second term, which is 4. And then for our third term, we are going to square or copy the last term and then square it. So after writing everything, we will now multiply or we will now simplify the terms. So quantity x squared is equal to x squared, and then plus 2 times x times 4, that is 8x, plus 4 squared is 16. Then we simplify everything. After simplifying everything, the final answer is x squared plus 8x plus 16. As you can see, that this the signs depends on the sign or signs of the terms. So be careful when dealing with terms. Always apply the rule in multiplying integers. Let's have another example for square of a binomial. This time, we are going to find the product of x minus 1 times x minus 1. As you can see, since the factors or the binomials that we are multiplying are still the same, we will still apply square of a binomial. And we let a equals x and b equals 1. X minus 1 times x minus 1 can again be written or rewritten as x minus 1 quantity squared. So this will be, x will be our first term, and the second term is 1. Applying the general formula for this one, we are going to square the first term. That's why we have x squared minus 2. 2 is always constant if you are using square of a binomial. And then x, again, this is the first term, and the last term is 1. And then plus, for our third term, we are going to write or copy the last term and then square it. But of course, we will not be accepting, or this answer is not yet simplified. So we have to simplify each term. So we have x squared minus 2x, y minus 2x, because the operation here is minus. That's why we have minus as the sign of our middle term. So we are going to multiply 2 times x times 1. So the result is 2x. And then we are going to square 1, and that is 1 squared. 1 times 1 is 1. Therefore, the final answer for this, or the product of x minus 1 and x minus 1 is x squared minus 2x plus 1. So, are you ready for the next special product? I hope so. So let's start it. Okay, the cube of a binomial. Let us have the cube of a binomial. The cube of a binomial can be expressed as a plus b squared times a plus b because of the law of exponents by actually multiplying, okay, that one. By actually multiplying it, of course, we will take so much or very long time. Okay, so to make it short, we have this pattern. So if you are going to multiply a binomial by itself 3 times, we are going to follow the following general formula. Please take note of this. So a plus b quantity cube is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. As you can see, we have here a pattern. Take note of the pattern. So as we can see, for the exponents of the variable a, in each term, it is decreasing. So we have here a cubed, then we have a squared, a, and then no more a. So this time, same is true with b. For b, it is increasing. Okay? So if you are multiplying things like this, same is true with subtraction. Always get the cube of the first term, which is a, and then plus or minus 3. 3 here is constant, and then square the first term, and then copy the second term, and then then plus sign. Again, we are going to write 3. This is constant again. And then you copy the first term, followed by the square of the second term. And then lastly, we are going to plus or minus b cubed. Take note of this. You may take a screenshot of this. Okay, let's proceed with our example. So find the product of x plus 5 quantity cube. To solve for this, we let a equals x and b equals 5. X plus 5 times x plus 5 times x plus 5 is the same as our given. And to solve for that one, first is we are going to get the cube of our first term, and then plus 3, that is constant already, and then square the second term, square the first term, sorry, and then copy the first term plus 3 times x times the square of the second term, which is 5 squared plus 5 cubed. And then simplify each term. Simplifying each term, x cubed is x cubed. And then 3 times, we have to multiply or simplify first what is inside the parentheses. So we are going to copy 3. So I just copied it. And then multiply x squared, or simplify that, that is x squared. And then 5 squared is 25. 5 cubed is 125. And then perform the operations in each term. Therefore, the final answer is x cubed plus 15x squared plus 75x plus 125. Always take note of the formula so that you won't be puzzled or to make the solution easier. Let's try it. What if we have x minus 6 quantity cubed? This time, the operation between the two terms is minus. Again, we let a equals x and b equals 6. So, x, we have to get the cube of the first term, minus 3 times the square of the second term. And then, the square of the first term, and then the second term, just copy it, plus 3 times the first term times the square of the second term minus 6 cubed. And then again, we have to simplify first the terms with the exponents and parentheses. So we have x cubed minus 3x squared times 6 plus 3 times x. 6 squared is 36 and 6 cubed is 216. Multiplying everything, the result will be x cubed minus 18x squared plus 108x minus 216. Okay, the last special product is the product of a binomial and a trinomial. So the product of a binomial and a trinomial can be expressed as the sum or difference of two cubes if they are in the following form. So as you can see, we have here a binomial a plus b, and then take note that this is only applicable if we have the following forms. If the binomials and trinomials that we are multiplying is in this form. The binomial is given by a plus b, and then the trinomials are in this form, the square of the a squared minus ab, the product of the two terms, and then lastly we have b squared. Otherwise, you cannot use this special product if the binomial and trinomial that you are multiplying are not in this form. So it is very important that you have to check first the given before solving. So if you are multiplying a plus b and the trinomial a squared minus ab plus b squared, the result is a cubed plus b cubed. And then if we multiply a minus b by a squared plus ab plus b squared, the result is a cubed minus b cubed. Or simply, we can solve this by simply getting the cube of the first and the second term. Okay, let's have the following examples. Find the product of x plus 3, x squared minus 3x plus 9. We can use that or this special product because this follows the format of our general formula. So let a equals x and b equals 3. Therefore, the product of x plus 3 and x squared minus 3x plus 9 is equal to x cubed plus 3 cubed. And then we have to simplify this further. So that is x cubed plus, we copy the sign. 3 cubed is 3 times 3 times 3. So that is 27. Therefore, the final answer is x cubed plus 27. Same process will be used if we have minus. So if we multiply x minus 4 times x squared plus 4x plus 16, we have to let a equals x and b equals 4. And then again, we have to get the cube of x, this one. And then we have minus the cube of the second term, which is 4. And then after that, we have to simplify. X cubed is x cubed minus, and then 4 times 4 times 4 is 64. Therefore, the final answer is x cubed minus 64 this time. I hope that you have learned something in this video lesson. You can apply and practice these skills by answering the activities given by your math teacher. And to sum this up, we have to review. Okay, so when we multiply product of two binomials, always remember the FOIL method. And if we have product of sum and difference of two terms, this is a formula, a squared minus b squared. And for the square of a binomial, that is, we have to take note of the formulas a squared plus 2ab plus b squared, a squared minus 2ab plus b squared. And then next, for our next is the cube of a binomial. We have to follow this formula. And then the product of a binomial and trinomial can be the sum and difference of two cubes. But take note of the patterns or on the construction of the equations or binomials that you are multiplying before applying the rules of some special products. With that, this ends our video lesson for today. I hope that you have learned something. If you wish to have more activities and examples, you may visit or check this reference. And that is all for today. Thank you and God bless.